This is CS 124, Lesson 1.1 Output. Today you're going to learn how to display text and numbers on the screen, how to left and right align this text, and how to format numbers to output a certain number of decimal places. Up to this point you should already know how to log into a Linux machine, and you should have written your first program, Hello World. If you wrote Hello World, you should already know about displaying text by using the command cout, followed by the insertion operator. All text outputted should be contained in double quotes. By contrast, when displaying numbers, the double quotes aren't necessary. We have more to talk about when it comes to formatting numerical output, but first, let's go test this out. First off, we'll just try outputting text using the command cout, followed by the insertion operator, and then our text in double quotes. Next thing we need to do is compile it and output it. It did exactly what we told us to do. It output Hello World. You'll notice it's all on one line, which is really easy to fix. All we need to do is add a new line character, which is a / and an N. So if we recompile it and output it, we get Hello World on its own line. Let's try outputting some numbers. We want this one on its own line as well. Another way to do a new line without putting it in double quotes is the simple command end L. So now we get Hello World and our number, both on their own line. So now that we understand how to output numbers, let's look at how to format those numbers. So far we've only used small decimals, but if the decimal were infinitely long, like the decimal representation of pi, the processor wouldn't know when to stop outputting numbers. In order to solve this problem, we have a certain set of code, written here, that tells us exactly how many decimals to output. Alright, so let's come over here and make this pi. Alright, and save. Alright, so we've got our decimal here, but you notice it cuts it off. The compiler didn't know how many to output. Let's tell it exactly how many we want by putting in our magic code. In order to use this code, you have to include a special library called iomanip. So make sure you add that up in your pound includes. We want this code to go before our cout statements, that way it applies in our cout statements. The last line here is where we tell exactly how many decimals we want to output. This number here, 3, tells the program that we want to output 3 decimal places, so it should output 1, 2, 3 places. Perfect. Now that you've tried out your magic code, we're going to show you a shortcut to make it more usable in other situations. You can use a set precision command inside of any cout statement, so if you want to see a different number of decimal places with different decimals, you need to simply input the set precision command after your insertion operator. Alright, now that we're back here, let's do a list of GPAs instead of Hello World. One trick to know about cout is you can do multiple cout statements on multiple lines. as long as you have a semicolon at the end. So we're going to do this. And don't forget your semicolon. So, if we compile and output, we can see I forgot my new lines. Let's try that again. There we go. So if we wanted to try our new code, we're getting 3 decimal places every time, which is what we told it to do up here. But let's say I want to do 2 here. So I'll just put in the command set precision and then the number of decimals I want. So we'll do 2 decimal places here, 4 decimal places here, and 1 decimal place here. We got 2, 4, and 1 decimal place. Hopefully now you understand the set precision commands. We're going to move on to a topic called alignment. Alignment is like on your receipts. On your receipts, usually on the left side all of the items are lined up, and on the right side all of the prices are lined up. We want to teach you how to do something like that in your code. The first alignment tool we want to talk about is the tab character. The code for the tab character is a / followed by a T, and you want to make sure that is inside of your quotes. Let's clear out our terminal. As you can see, it moves everything over a tabbed amount. One thing to note about the tab character is it's actually not a set number of spaces. The number of spaces that are outputted by the tab character changes depending on your processor. If you want to make sure that your number of spaces you output is constant, we have a different set of code for that. The code to set width is sort of like the code to set precision. It's just a set W followed by parentheses and then the number of spaces you want. So in this case we're going to be doing a 9. Set width automatically fills from right to left. So let's say we've got 9 spaces. And we're going to output meow. What will happen is it will start here on the right side and fill in the text that's been given. And it will leave the extra spaces over here. So you'll see we've got 4 spaces filled and 5 spaces left empty. Say we were to see out hello world instead. We'll take our 9 spaces and start filling from the right again. Space. The problem is there are only 9 spaces available to us by our set width, but there are more than 9 spaces needed to output hello world. So what happens is it truncates the H and the E. So make sure you're careful when you're setting your width to make sure you don't cut off more than you mean to. In order to demonstrate this concept, I've set up a table. We have students on one side and their GPAs on the other. As is, we get this output. Now what we want to do is format it nicely like our receipt, with names on one side aligned to one way and GPAs on the other. In order to do this, we're going to add our set width command set W, and then the size. We're going to do 10 spaces. And just copy and paste. But make sure you get your parentheses closed, or you can't compile your program. Let's add another set width here, because we want these to be aligned to a different side. Now you'll notice all the GPAs are aligned over here, 10 spaces away from the names, which are aligned over here. Another thing to note is everything is right aligned. This is easy enough to fix by simply adding the command left. So now the names and the GPAs are both left aligned because left is sticky. If we wanted one to be left aligned and the other to be right aligned, we'd have to do the right command like this. These commands are sticky, which means they apply to everything after them. You'll notice that the left made everything left aligned. So in order to switch back and forth, we need to make sure we've got them lined up. Now it may look like it's increased the number of spaces, but if you look up higher, you can see here, just like above, the GPAs are right aligned, and the names are left aligned. Something else to make our output look nice is a header. This is something you'll end up doing in your functions later. That can look something like this. Now let's get rid of all our left and right commands and just keep everything right aligned. Okay. Make sure we recompile after we save. And get all of our semicolons in the right place. Oh, and I forgot a new line. But see how nice that looks. We've got our names on one side, our GPAs on the other, and our header to label everything. You can format this however you like.